Hi, welcome. This is JP. Welcome to the first video of this channel. We're gonna be talking about inverse kinematics, game development in general, but I'm gonna give you an overview of the first series of videos that I'm gonna be doing. Basically, we're gonna do 2D inverse kinematics. The animation, I'm gonna show you how to animate it, how to do it so it hits the floor perfectly. And right now for this video I just want to give you a quick overview because I'm preparing the tutorials for the whole series. So here's what we're going to be doing. I have this these two legs. I just have three bone sprites. They're just white. I just colored them so you can see what's happening. And I have this the targets. So the chains follow. They each have their own target, so they follow that. As you can see, right now I have an offset, so it's not following. It's supposed to be following from this point, but it's offset here, which is on purpose because I want the floor. As you can see, if I put this to 0, I know that the floor is going to be at this line, but I want the foot to be above that line, so I have an offset there, and that will change depending on the angle. So basically that's what the inverse kinematic or the change will do. It will follow a target, and it will allow you to offset both the position the position and also the rotation, which I found it to be quite important. So let me show you, for example, let me just hide this ray here. So if we grab the hip, as you can see, it will just follow the targets. There's a little bit of a delay when it follows. That's actually on purpose, so it doesn't just snap to the target in case the target changes abruptly, which is actually quite important. So if I hit the -50 here, you can see that it doesn't snap to it. If it didn't have that sort of bounciness, it would just snap to it. Which would be fine if it's a little gap, but for larger gaps it doesn't look that great. And actually we have a small algorithm to know when the gap is large or small, because if you see, once it's really close, it just follows faster, but if it's a longer way out, it doesn't follow as much. We can tweak that as well. Okay, let me show you the animation here first, and then we'll see. Let me just slow this down. Okay, so we have this animation. Because we're using the targets, it's actually pretty easy to do. We have this target here, which is this track. First keyframe is there, second keyframe just goes back, and then when it's going back to the first position, all it does is a little lift, right? So it just lifts. So those 3 keyframes to do this walk. But of course you can do it you can do a more sophisticated, more detailed animation. But this is fine for now. Okay, and the left is doing the same thing, just obviously at a different phase. And actually, what's actually cool as well is if you want to walk back, all you have to do is move this keyframes to the other side, and it will walk back. The rotation of the feet is wrong, but that you can just fix that here. So that's pretty cool. All right. Now what I have here, for example, as you can see, I'm not messing with the rotation directly. I am using a rotation that I have set up myself on the IK. This is I'll show you what this is used for, but there's actually an offset for the angle as well, kind of like the offset for here. So if the floor is at a different angle, we keep this angle so the animation always works the same, but we offset it so that it matches the floor angle, and then you don't have to do that much. The code is really small to match. This is matching the floor, so yeah, it's pretty cool. Let me show you how it works when the floor changes. So let's hit play here. Okay, so right now let me just hide the targets first so we don't have them on the way. So the floor right now is just following my mouse, just for demonstration purposes. So as you can see, the angle, it's not changing right now, but it's following the floor. And as you can see, the rotation of the foot with the animation, they basically stay the same. So when he is going to lift the foot kind of points down, and once it's about to land, it points up. Okay, and the reason we have the offset is because if I change the angle here, which if I press spacebar, for example, it will rotate around the root of the hip. So if I change this angle, you can see that he still points down when he's lifting his foot, and his foot points up when he's about to plant the foot. That's why we have the offset. And the offset is the procedural part, and the keyframes. This rotation basically matches the floor, and then we procedurally just offset the angle to the floor. We're using a raycast here, and just show you what the raycast is doing right now. We just need the raycast right now just to know what's the floor normal. So, right. So when it changes, if it rotates, the raycast, it's also following the mouse. Okay. And if I hit enter, it stops. Now, because as you can see, because I have that slight delay, when he stops walking, it doesn't snap back into the other pose. And what's cool about this, I'll show you on another tutorial. Well, actually, I'll show you in one of the tutorials. You can blend animations, so you can have a walk animation, and for example, you could just move this one down, and you already have a crouch animation. And using a blend tree, you can map the crouch height to, for example, the axis of a joypad or anything that you want. So you're not stuck with just he being here or here, but you can actually, you know, just move between these points using the blend tree, which is pretty cool. You'll see it later. Yeah, that's it. So that's pretty much for now. I'll explain a little bit more about how this works on the next video. What type of algorithm we're using, how are we doing the math, and how we have the setup for the bones, because it's a little bit different than what you probably used to. Yeah, so that's it for now. That's the quick overview. If you have any questions, let me know in the comments, and we'll see you in the next video.